Ladies and gentlemen, welcome back to our last session of the day in room 9. The session will be multi-application architecture, presented by Kamil Sacek and Jeremy Viska. Thank you.
Hi everyone, I welcome you on our session. I hope that you enjoy this conference as we are already, because we are after 2 days of workshops, which are very good thing how to find new information and meet people. And my name is Kamil Sacek. I'm working as a software developer, but right now I'm managing our product development in company Navertica from Czech Republic. I'm MVP since long ago. I will not bother you with the date. And I'm here not alone, because I have my friend here, Jeremy.
Hi everyone. I've been working with NAV and BC since the year 2000 as well. And the ink is still drying on the MVP, so don't touch it too much.
It means, Jeremy already told that it's meeting of someone old like me, old MVP with a young MVP, we will not continue in that part. Okay, we will talk about the multi-application architecture. Since today, I think there was no session focused on the architecture itself. It means maybe the session is somehow different than you already had today, about the tools you can use and how you can produce code in the best way without nearly touching the keyboard, just looking at the display and it will type everything for you. That's nice, but producing code just without any architecture, without any patterns or target we want to hit with that code, it will lead to something we don't want to use anymore, and we can't support and we can't upgrade, and nobody will pay for that anymore. But first, the question is, what does it mean, architecture? Architecture, we know that word around us. We see building and we see that's the architecture of 18th century or something like that. There are few quotes about the architecture in software development. First one, architecture represents the significant design decisions that shape a system, where significant is measured by cost of change. Grandi Booch. You know that name, I think, for example, from university, because Grandi Booch is behind many things in software development. And we can see that architecture is a set of decisions you are doing during the development itself. These decisions are leading you somewhere, and you can measure if the decision was good or bad. For example, based on the cost of change, but not cost of change now, but cost of change in future. Because if you have good architecture, the cost of change of, for example, adding one new field, and you know that it's every time it's only one new field the customer wants to add there. Yeah, and then there is another one field I don't need anything more, just add that field and that field and that field. The cost will be constant for you. Yeah. I will let it grow up. If we have a good architecture, sorry, my clicker not working. We are on the constant line. And even in 10 years or 20 years, the cost will be same if I want to do the same change. If I have a wrong architecture, and you know these cases when the architecture is wrong, the cost is going up, linearly or exponentially, doesn't matter. Yeah. Those are the monoliths on NAV, which are still on version 2.6 or 3.6 or 4 and 5 and any other version, and they are not able to upgrade anymore. They are not able to extend the system anymore. They are not able to change anything anymore. Because if someone asks someone, please, can you change that? No, 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 I will not touch that. Yeah, because something else will break there. I don't want to break your posting because I added a new field in that unimportant table. Yeah.
And additionally, on top of that, you also get into the challenge of try to find information about 2009, setting up a new web service and getting the SPNs just right. The documentation keeps up with the version, so there's a higher and higher cost of just supporting those older customers.
It means don't forget about cost of change. We will speak about that mostly. Another quote. When software is done right, it requires fraction of the human resources to create and maintain. Changes are simple and rapid, and defects are few and far between. Effort is minimized, functionality and flexibility are maximized. Yeah. That's from book Clean Architecture from Robert C. Martin. You can know him as Uncle Bob, for example, on Twitter. And again, we are talking about some measurements and some values which are affected by the architecture. If I put it to some chart, it looks like that. The blue one is maybe something like current state of your system. I don't know. That's just example. We have some human resources we need to do some change. If we are doing good architecture, we don't need so much human resources. It means one developer can do more work in that system with good architecture. And I think that everyone knows that it's hard to find developer for AL. Yeah, every partner is struggling with that. We are searching for developers anywhere. Yeah? We are taking anyone who is able to write the code. Just applying correct architecture could save your capacity on the people. Second thing, cost of change will be lower. Yeah, the clicker is correct. It means we are saving money of our customer, because if they need something to be changed, it will not cost them higher money in 10 years, for example. Defects, there are few defects if the architecture is good, and you change one piece somewhere, it will not break something which is not connected with that part. If you have wrong architecture and you touch something, something else will break. Yeah. And even that part will save you capacity of the developers and consultants, because they don't need to spend hours and hours to solve different problems of the customers just because someone changed the layout of the report and customer is calling, hey, we can't post now. Why? We changed only the report layout. Yeah. Who knows why it is not working anymore? Another part, effort. Of course, if you have a good architecture, you don't need to put so much effort into the changes and so on. And with good architecture, you will have better functionality and better flexibility. And those are two things which the customers will understand, because customers need flexibility and they need functionality. The COVID proved that, because the companies which were not flexible enough, they didn't make it. If you just imagine the restaurants, on beginning of the COVID, who was flexible, switched to deliveries, make the e-shops to send their meals or sold their meals to their customers, and so on. It was really fast change for them. And if they were flexible, they are still working. Who was not flexible, they're gone from the market. Another quote. Sorry. The goal of software architecture is to minimize the human resources required to build and maintain the required system. Yeah? It means, again, we are talking about the human resources. Architecture have impact on that. And you need to be sure that really you are doing good architecture, because elsewhere you are spending your capacities on something which is not productive for you. One more quote: the only way to go fast is to go well. Yeah. Again, Uncle Bob. Yes, if you have good architecture, you are faster to implement the changes, because it's ready for you to change the system. Doing system in a way which is preventing me from any changes is dead end. Yeah? If you hit something like that, yeah, just run away from that decisions which will lead you to that end. If you think good architecture is expensive, try bad architecture. That's a very nice sentence, because I think many partners went this way already. And everyone who implemented NAV or Navision before NAV, those were bad architecture, which leads to things which I was already talking about. Yeah? The monoliths which are not upgradable, and you need to throw them away and re-implement everything again from scratch. And again, the price, the cost of the change, we need to think about that. Making messes and clean them is slower, always slower than stay clean. I don't know who says that, but I know that Valdo approves that. Yeah? Just ask him and he will tell you, yeah, you need to stay clean and do everything in correct way, because elsewhere you are throwing out work of your people from the window, and you are losing your capacities on something you don't need. If you want to know more, don't forget to go tomorrow on his session about bad habits of AL developers. And last thing, no quotes anymore, but last thing, we are creating software. Software, that's the part soft, means it's easy to change. And software was created to be able to change behavior of hardware, which is hard to change. Yeah? Don't forget about that. We are creating software. It means really we should be in a way that we can change it easily, and don't produce hardware in your code. Okay? Now prepare your phones for a short and small pool we prepared for you. I want to know how you will see those 2 questions I will show you. Just scan the code and you can vote on the pool. Sorry, poll, not pool. You can vote on the poll in your pool if you want, but yeah. The question is, what is better? Software which perfectly works but is impossible to change, or software which doesn't work but is easy to change? Yeah. It means I have something, it works, it have all the features I need, but I can't change it. Or software which doesn't work, but I easily change it. And there is one quote that's, you know, that software could be reduced to 1 line of code, which is wrong. Yeah, that's the software, and we can do that. Yeah, but I hope that you are not producing this line of code which is wrong. I hope that you already are polling, sorry, still. The tablet is not working with me. Okay, I switch on the poll. Ball. Let's Yeah, I need
Mirror mode.
to duplicate that. Yeah,
That's pretty good.
I think it's very good. Yeah, that's okay. It's not moving anymore. We have over 150 people for the second choice, 23 for the software which perfectly works. Good one. And I will go back to the presentation which I closed accidentally. Okay. The result, of course, yes. The software which doesn't work but is easy to change is better. Yeah. Because we can change it easily to work correctly. Yeah. It sounds I don't know, first time when I heard that, oh, it's interesting that something which doesn't work is better. Yeah. But yes, we need the flexibility. We need to be able to change it easily, even in future. And now if something doesn't work, it's just question of few minutes or hour or something to fix it. And it will work. And you can add new features.
Yeah. I don't know how many of you played sports when you were young. I was taught by a bowling coach. I want you to bowl terribly. Your very first thing you should do is learn how to do it wrong, the same way every single time. And I thought that was one of the weirdest, strangest pieces of advice I had ever gotten. But the difference is that if you are consistently doing the same things, they are adjustably consistent. So if you're using the right techniques, the right patterns, the right designs, even if you're not getting all those happy little green check marks for all the tests you're all writing, right? Then at least you've got the pattern and the structure in place.
Yeah, and if you are doing some architecture, of course, on beginning it is slower until you get that into your fingers when you're typing the code, and then it's faster, and it starts to be part of your thinking and everything. Yeah. Okay, it means cost of change matters, and design matters. Don't forget about that. Short intermezzo. Who knows what Eisenhower matrix is? Hands up. Few people. Okay, that's good. Something new for you.
Yeah.
If nothing about the design will give you something else, hey, it's good, then at least Eisenhower matrix, and you will know how to manage your time. Now, Eisenhower matrix is about important versus urgent things in your life, yeah, during your work or during your everyday schedule. It looks like that. Those are the three variants of the same thing. One axis here is not working. One axis is important things. That's the top line of the chart. Not important things are on the bottom. Urgent things are on the left, and not urgent on the right. And what is telling us that matrix? If I have urgent and important thing, I should do it. That's the high priority task I need to do. If I have important but not urgent thing, it means it is not urgent now. Maybe it will be urgent in few days. Yeah? But it is important. I need to think about it and maybe schedule it for later. But I will need to do it. I just plan when I will do it. It is not urgent. It can wait for a while. Urgent but not important things. I need to do that now. But who cares about if it's not important? But we tend to do these things. Yeah. because we like the urgent things. There is pressure on us, and we are just trying to do that, but then someone will just say, why you did that? Nobody wanted to do that. It's not important.
The downside to Teams integrations.
Yeah. It means not important and urgent, and not important and not urgent things. Those are the things which we like to do because they pleasure us. But you are just losing time on that. Don't do these things if you want to use your time productively. Yeah? Not important things and not urgent things. Just delete them from your life. And it have one impact, because important, yeah, we need to think about it again, sorry. Just example, there is a fire. And of course, it's urgent thing. Yes, you need to call the fire department, it's urgent. Because you need to call it now, not tomorrow or something. Then you will write an email, fire, yeah, help me, let's call for the help of fire department. But important, yes, it is important if you are in danger, then you will run or use the fire extinguisher and so on. If it is not important, because the fire is over the street there, and who cares if the car will just be totally destroyed by the fire, it's not important for you, then you have delegated it already to the fire department, and you can continue with your work. And that's the difference between features and architecture. Because features are urgent things, mostly because customer and managers want them now, or at the best, yesterday. Yeah. But architecture is important thing. Architecture is important because it have impact to the future things, to the future costs of changes and so on. And because one is urgent and one is important, there is a tension between these two things. And if you know about that, it will be easier for you to solve these things, because features are urgent, architecture is important, managers and customers want the feature, but we tend to prioritize the urgent things, it means the features, and we are forgetting about the important things. And this is architecture. And that's the reason why we are producing features and we are not thinking about the architecture, or we are pushing the architecture somewhere, okay, we will think about that next week. Not today, we don't have time for that right now. I need the features because the customer is going live tomorrow. No, architecture is important. And mostly the features are urgent, but not important. It means you can delegate them to someone else, if you have someone like that. Yeah? Me as a manager, I will delegate that features to my young developer, and I will just focus on the architecture. I will tell him how it should look like, the rules for the architecture, and he will implement the feature. I don't need to implement it. I will just think about the architecture for himself because he don't know all the things around, for example. But architecture is important for everyone in the team. Yeah. It's not problem of just architect or consultant. It is things for everyone in the team. Developer, consultant, architect. Of course, not manager, because manager just hired developers and consultants to do that work because he don't need to understand the architecture. And it means the development team is responsible for the architecture. Don't ask your manager if you should do it in that way or that way. It's your responsibility to decide the architecture because you are thinking about the cost of change in future and that it will save your work in the future. Yeah. Manager needs to know that it will be cheaper in future for the customer or even for your company to do these changes and so on. But we will talk about that later. Again, the matrix, don't forget, architecture is important, features are only urgent. We will talk about some principles, and these principles are you can apply these principles on different levels of your code. You can implement them on a level of functions, objects, source files, or modules, applications, or some component solutions which are composed from multiple applications, for example, together. It doesn't matter. We will mostly focus on the application level, but you can apply them everywhere during the development.
So one of the challenges whenever you're thinking through principles, design, rules, architecture, is it's hard to hang those ideals without there being some sort of story to connect that to, especially since most of you are going to be going back and trying to explain some of these different principles to people. So what we're going to do as we go through each of the principles is we're going to follow along with a company that we've invented that is a monolith. They've gone through the traditional process of you make a big giant solution, it's one big PTE. They had initially exactly what they needed. They could book little bouncy castles for children or fun adults for the day, and they've expanded to add some new lines of businesses. But they know that they're growing and growing, and there are many different booking systems, so they know that they need to break up that monolith. All of the stuff is tangled together with that booking system, so there needs to be a plan. And the principles we're going to go through is how do we break that up for that company? And it reflects a lot of different projects that we've worked on over the years, taking that journey version by version to getting a good solution.
It means, yeah, that's the Amuse You company. Okay, and now we will talk about the principles. We want to show them and introduce these principles to you, and we want to offer these principles to think about every decision you will make during the development and think about these principles, how they are impacting my decision now, what will be effect if I will break that principle or if I will apply that principle. These principles are part of a solid framework or solid principles which were described, for example, in the book Clean Architecture from Robert C. Martin. And the solid are the first letters of these principles. We will talk about single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Okay, begin with the first one. Single responsibility principle. What you can imagine under that? I will try to demonstrate on the car. That's the single responsibility principle which is not used in that car. Yeah. Can you imagine that this principle was not implemented in your car? That there is only one driver responsible for driving the car? Oh, it will be very, very big boom, I think, after you start the engine and start your trip. Yeah. It means that's the responsibility principle in reality, in car, if we break that. And we are doing that in software development every day. Yeah. We are breaking that principle and then solving the effect of that. What is telling us? A module should be responsible to one and only one reason to change. Reason to change is, I'm changing it because, for example, that process needs to be changed. I don't change it because another process needs to be changed. In this case, I can have a conflict, and it means I will change it because that process changed, and then I will break this second process because it's using the same part of my system. The part was responsible to two masters, if I tell it in that way. You can't serve two masters. You know that. That's the single responsibility principle. Different definition is telling that module should not be responsible to one and only one user or stakeholder. It means if you have one end user who is responsible for some process, there should not be any other user telling you, please change that app for me because I want something to be changed there. Same for actor. If you identify some actor in your app, for example, some doctor for which you are doing something, or the one who is doing the reservation of your e-card tracks or something like that, or bouncy castles, there should be only one person responsible for some part in your software. What is module? In our case, module is unit of deployment. Mostly it's app. It have own version and you are deploying separate app. That's the module. But again, you can implement that on any level, and for example, function could or should be responsible only for one thing too. Yeah? If you break that, you can have possible problems.
So if we take our example and we look at the company that we were talking about, if we start looking at their organizational chart, they've got 4 managers. We know that they have all these different needs that are all being served by one monolith. So right now, when we have to ask the question of what should change, we have to ask all 4 of these people. So our first pass on the solid principles is to go, what are the individual extensions as far as who's responsible for them? When I, at the end of the day, have to pick one person to say yes or no to a feature change, who is it? So we break it down by organizational structure, and then we start with that as our first pass to create initially the framework of what are all the different parts of the system that we need to pull out of that monolith. Yeah. And that gives us maybe a better plan than monolith. I suspect a number of people have built something along these lines where you said, okay, well, we've got these 5 different lines of business, and all of them need to make use of this booking system. So we'll make the booking the baseline app that all of these other apps are dependent on. That's going to work out, right? Remember that they want to remove bookings later. So that's not quite going to be the plan we need yet.
Yeah. It means if we are thinking about single responsibility principle, you can implement everywhere. Standard example of breaking that rule, a reservation table. What is responsibility of reservation table? Reservations and item tracking. Yeah? And why that was not changed until now? Because it's hard to do something with that, because there are 2 responsibilities, and if you change one, you will break the second. Yeah, that's a hard thing. Of course, monolithic applications, again, who is responsible for the monolithic application? If you want to ask someone, if you want to change something, who you will ask? You will need to ask everyone if it is okay for them, or yeah, because there is, or no one, and you will do it, and someone after that will tell, oh, something was broken for me. Yeah, you didn't tell me that you want to change that, and yeah. That's the single responsibility principle. And what can help you? Ask, what is the responsibility of the app or function or component or object if you are thinking to modify it? You need to know that. What is the responsibility? Who is responsible for that part? Is he accepting that change? Yeah? Or have some additional info, for example, for that. Ask the questions. You can add this information to your user stories in DevOps, for example, to see that who is responsible. Maybe it's responsible the one who is assigned on that user story. And then if you detect that you are implementing 2 user stories on one app and each user story is have different responsible person, then ask these persons if it is okay or there is some conflict or because there is possible problem for you. And don't create multi-purpose objects table and apps. Yeah, definitely not the tables which are having multiple fields and based on some options, some fields is used for that record, something is used for that record, because you need to save 3 ID tables because the customer will not buy any other package of 10 tables into your, the license.
I just helped a customer upgrade a monolith application where they had a table literally called the multi-function table, which had a primary key of just 2 codes and a description, and they used it for 50 different settings pages.
Yeah, I know most of us knows these cases. Yeah, when the architecture was sacrificed just because some money must be saved somewhere, but you will pay it multiple times later. Another principle, open-closed principle. What does it mean, open-closed? Yeah, okay. We have a truck which is components of 2 things. Yeah, there is a tractor and semi-trailer. Sorry, the semi-trailer is the second part of the truck. First is the tractor, and open-close principle is saying I can change the semi-truck without need to change the tractor. In this case, I don't need to change anything on the tractor to be able to connect another trailer to that tractor, because there is something prepared for that. Yeah? And I don't need to change anything in the closed system of the tractor itself. Software artifacts should be open for extension, but closed for modifications. And if you think about that, that's AL. That's what we have. We have core app, which we can't modify, but we can extend it. Yeah. That's the core principle of AL. Changing by adding, not changing existing. And we need to use that principle. But you are using that principle already. You didn't know that it have name. Yeah, now you know that it have name, and it's open-close principle. And of course, there are some tools which are helping us with that. For example, Valdo's generic method pattern, yeah, who is implementing that, he knows that you are implementing that to be open for extensions. Yeah, because you are closed and you don't want others to change your app, but you want to extend them by some ways. Eventing interfaces, standard way how to extend your application without changing it. That's the open-close principle. Separate the functionality based on how, when, and why it's changed, and organize the separated functionality into a hierarchy of components. It means you have multiple applications which are depending in some ways on each other and doing that hierarchy. And there are some rules, we will talk about them, and it's based on how and when these applications are changed and so on. And that's another one. Yeah, if we are doing that hierarchy, we are doing that high-level policies, central concern, business rules, and peripheral concerns, which are specific implementation somewhere or low-level access, for example, to some printers. The apps are depending in some specific direction. Yeah. And these are the rules we can apply, and we will talk about them later. Low level is mostly depending on the high level application. It means core application from Microsoft. That's the central business rule application of the solution. Those are the rules which are applied through the system. How the sales order is changed to sales invoice, and sales invoice is posted to GL entries. Those are the basics rules, and you can't change them. That's why you are depending on the core app, not core app on you, because that's the highest level. And lower level is some process doing something which is okay. If it is not working, it will not break the functionality of the rest, and company, for example, could still work.
Okay, so taking that open-close principle example, which we're doing better than the workshop. Most of you folks are still awake. We lose a lot of people by the O. In the open-close principle example, the partner implementing the booking system, they're doing what they should be. They're creating a whole lot of events. That makes that component extensible. They can do that. Many of you are already doing that today. So that seems to make sense. In this plan that we had built, we're going to create events for on booking canceled, on booking confirmed, all sorts of different things. So we're keeping that open to the possibility of change. Quick aside, I'm going to steal a little bit of Waldo's performance information. If you are publishing events and nothing's subscribed to it, there is no cost to performance. He did lots of testing on that. There is no harm for performance to open this application up. So make the application very, very open to those possibilities. But as we went through in detail in the workshop, also verify. If you pass off information to events, you don't know what you're going to get back. So be open, but don't necessarily allow people to make the changes directly in things.
Yeah, don't expect that the subscriber will play nicely with you. Rather, validate everything what you are getting from that subscriber back to your code. Yeah, that's on you, and you are responsible that you will not fail if something wrong is returned to you, or you will react nicely for that. For example, with nice error message, someone give me something I don't know what is it. Yeah? That's on you how you will handle that situation. But be nice, and if you are consuming, you are extending another application, be nice and play nice with that application and keep their rules how to extend their applications. And of course, everything like that is helping us as a partners, if we are partners, to interconnect our solutions together. And of course, if I am partner responsible, and I have single responsibility in my app, yeah, because no other partners is responsible for my app. I'm responsible for adding additional, even if someone wants to extend my app, I will put that even there without no problems. I don't have any problem with adding that event. Why not? I'm happy that someone else will use my app. Yeah, use it. I will put it everything what you want. Not everything, please. Yeah, put what you think that is good for you, of course. And if someone wants something which is against your design, don't put it there. Solve it in a way to keep your design nice and clean and simple.
Be careful the way it is handled.
Yeah, and you know that it's a really good habit to be able to say no. Yeah. We are mostly saying too much yes to our customers, for example, and then the customer is saying, "Why you allows us to do that? You are the expert, which should say no to that." Okay, you will try once, and they say, "But we want that." Yeah, okay, but we told you not to do that. Open close principle. Use the known patterns to open your app for dependencies. Of course, I think you already heard about the website which is created just to describe different patterns we can use in Business Central. Just open that website, go through the patterns. Let your other developers know these patterns and apply these patterns. Of course, think about that if you are not overthinking some things and you are not doing things too much complicated, but there are really good patterns to follow.
That might be a good in-the-room poll. Does everyone here know about the patterns website he's referring to? Show of hands. So
Yeah,
pretty
so I
good
think it's pretty
population.
good, yeah.
Okay. For the folks in the room who don't know, alguidelines.dev. Bunch of best practices. It's all GitHub populated. Anyone can contribute best practice and patterns.
Yeah, and if you have good practice, then just describe it there, share it with others, because everyone will gain something on that. Do not change the existing code if the kind of the change is different than the original code. It means don't do anything in the code if the change is totally doing something else, because you are introducing another responsibility for that function, and there will be conflict in the future, for example. Rather extend that application with new application, and you will not break that one, and you will add new functionality through new app, which will play nicely in your system. Check if the dependency is in correct directions. The low to high, yeah, it means application which is not so important is depending on the important one. Things which are just low-level access to some external system, for example, integrating you with external warehouse system. These applications should depend on other applications in your solution which are implementing business rules. Specific to generic, it means specific implementation of something. For example, protocol for sending SMS or emails or something like that should depend on generic applications, which are just, for example, implementing some interface for sending some notifications. Those are generic things and specific things. Not stable to stable. What is stable application? Stable application is application you are changing maybe once per month because you are just doing some cleanup. That's stable one because, for example, it's implementing business critical things, and the business critical things are not changing every week. But maybe you have something else, some app you are changing every week, because every week some customers or the customer comes and say, okay, can you add this field here and this field here, and you added this field last time, but we don't need it here, but it should be there. Yeah. This is unstable application, and doing that unstable application depending on the stable one, you are protecting the stable one from the changes in that unstable. Because the dependency know nothing about the depending app. Yeah? If low level depends on high level app know nothing about the low level. It means if you change low level, it will not have effect to the high level, or should not have, if everything is okay and design is okay. Next principle, Liškov substitution principle. If we have a truck, we can change the trailer on the truck without changing anything on the tractor. Yeah. It means we can just substitute part of the system for something else, and the rest of the system will not notice anything about that change. It will still work. It has no effect on the tractor. Okay, maybe he needs to hire performance or something to keep the speed with the same more heavy semi-trailer, but yeah, it will work. You can substitute part of the system without effect to the functionality. Introduced by Barbara Liškov in 1988. That's a principle from '88. We don't know about that. Now we are part of the world of developers, and they are knowing that principle already so long. Yeah. Why we are not implementing that? We can. Yeah. You can replace one part without with something else without need to change. on depending part without change of behavior. And if you implement that, it allows you to, for example, totally change one part of the system, how it is programmed or how it is working. Just take it away, put something new there. It will not have effect to the system. It will not break anything. It will still work. What, for example, now from my head, what is good example of Liškov substitution principle? The thing which we are now going through since Microsoft bought NAV. Microsoft totally changed the framework behind NAV and Business Central. It still works, mostly. It still works. Same code which was there 20 years ago, it still works. Yeah, it have no effect on the function. Of course, we needed to change on the ways with many things, but in general, it's changed part of the system without effect on the rest of one. Yeah, nice example. I think it's, of course, if you just forgot the details. Originally about superclasses and subclasses, but could be applied on AL. And the solution for Liškov substitution principle is interfaces and events. Because we have them, we can do that. Because we can do the dependencies in different directions, and then it allows us to take something from the system and put something else there. Violation of substitutability causes pollution with a significant amount of extra mechanisms. It means if you see the code, if then else, if then else, if then else, or if something is something else, then do something, and if it is something else, there case, and so on. Those are marks that you break that principle.
So to apply that example, when we talked about, we came up with this first plan. We said, okay, we're going to break up all these applications. They're going to depend on the booking system. When it comes time that the company is going to replace it with a web-based one instead of a BC-based one, we pull that out. Uh-oh. So often, as a partner, you go, okay, well, forget that. We can't break it up in that way. That's obviously not going to work for us. So we'll build a big common, like shared application. And for older versions, for performance reasons, we're going to stuff everything in there that's data related. We'll put tables and extensions in there, but all the functionality is now nicely separated. So later on, when I'm going to pull the booking system out, in theory, as far as the dependency tree is concerned, we're not going to have a problem, right? Should be fine. Unfortunately, they've just moved the problem to somewhere else. We'll see. So when we move things down to the common, we try to be smart about it. We say, okay, we'll make in the common layer some sort of management code unit, already a danger word for those of you who haven't heard the term Swiss Army code unit. Yeah, management code units are a sign of that. So in that case, we have a function in here that the bounce units will call to say, okay, I know about bounce, and when that event gets called by the bounce app, it will fire an event, and bookings is listening for that event. So I've now decoupled those two extensions. They don't know about each other. This should solve the problem, right? Should. Now when the booking goes away, bounce is still calling that function, the event is still firing, but we don't have a problem anymore. We don't have a booking system connected to BC because we haven't replaced it, but we don't have errors. So now that we've broken at least one of the dependency hooks that's in here that prevents us from easily changing an individual part of the system. And that massively reduces one of the big costs.
Yeah. Regarding the Liškov substitution principle, if you tend to put new if then else or case to make something different in some enum options, yeah, if my enum is that, do something else, consider using interfaces. Yeah. Classical example, sales line type enum. and the code which is connected to that sales line type. Yeah? If you are posting item or posting GL entry or resource or car or bike, you will see in the code many if then else or cases which are solving that. If posting for items should be posted during the posting or something else. If there is implemented interface, you will not have these cases. It means, yeah, if you tend to put the case like that, then consider interface. Use interface whenever it's possible. That implementation of the specific process function could be different for different cases. I had a case with my colleague. He analyzed one customer's needs. Customer told us that he needs 6 processes to be implemented. Okay, so 6 processes, it will be so long to implement that we don't have capacity for that. And my colleagues analyzed them and found out that these 6 processes are in reality one process for 6 different things. It means same steps, same tasks were done with 6 different things. Once it was fixed assets, once it was item, once it was some job, once it was some task somewhere else. Yeah. It means we can implement one process with some interface and implement 6 specific implementations for this process. Do not depend on the specific implementation. If you are doing something like that, develop the process for unknown. Yeah. If you take sales order and you will create the process of posting sales order for unknown sales line, yeah, I don't know what will be sold, if it will be item, car or something else. I will do it in generic way. And then I will implement the specific implementation of the interface for items, for resources, for something else. Try to think about unknown things, replace these specific things with unknown, and you will be more generic. If something should be interchangeable, of course, the inputs cannot be stricter. It means if there is some implementation which allows only minus 1,000 to 1,000, the new replacement cannot accept only 100 to from minus 100 to 100, because it will error out if my generic process sends 500 there. It will fail. Yeah? It means it cannot stricter the inputs, and outputs cannot be wider because the rest of the system is accepting some values, and now you send back something which is out of the bounds. That will fail. Next principle, and we are going to nearly to the end. There is only one principle in front of us after the interface segregation principle. Interface segregation principle. I was thinking hardly how to explain that on cars, but I came with that example. We are working on something what should work with cars, in generic cars, yeah, any car on the world. I will create some interface working for cars, having some functionality for cars. And now I have truck, and now I have a personal car. I need new functionality, which is available only for the trucks. I should not put that functionality into the same interface, which is for all the cars. Because interface segregation principle is telling us that the client should not be forced to depend upon interfaces that they don't use. It means if I put some specific functionality for trucks and I will implement that for personal car, I will need to implement even that function for the trucks which have no meaning for personal car. I'm polluting the interface with something what is not used with all the clients. Yeah. And the same principle works for the dependencies. Yeah. We don't want to pollute application with dependencies on other application if the application needs that only for one small part, for example.
Yep. So to bring us back to this example, you know, we had the bounce units calling this little management function, and that threw an event. And the event tells the booking engine, okay, we have some info. This unit that is going to be booked, it's no longer available. Well, you know, the VP of the paintball fields has decided we should also have the ability when we fire this event to include the list of all the players that are coming that day. So I want you to add to the interface a list that I can then theoretically, in the event of bookings, read that out, send off information to lots of different people. Well, that's really cool and all, but if you remember correctly, our bounce management also uses that same interface. And so now we're having to provide an empty list for something that doesn't matter. It's not relevant to that. So the idea of this one is that if you are creating generic interfaces, they should not be polluted by functionality that is specific to a particular module or part of the system.
Yeah, that's the case when you extend such an interface, you are forcing all who implement that interface to implement this new function, even when it have no meaning for them. And they will implement it in a way that maybe it will break your processes. Yeah. That's the pollution, and you don't want to do that. Rather, you will create new interface, which is only for the paintball fields, and have this new functionality. And then if you have some specific paintball fields, because, for example, you have outdoor paintball fields and indoor paintball fields, they will have this functionality implemented and will use it, but no others which don't need that functionality. If applications are loosely coupled, and now I'm talking more about the dependencies than just pollution in the interface. If applications are loosely coupled, don't make them dependent. It means if I have application, sorry, I will go to the, I don't have that picture there. Okay, sorry. If I have application A and B, and I want to have them dependent, A depending on B, and when I remove B, A still should work because they are not tightly coupled, or they are loosely coupled. The dependency cannot be there. Think about that. Each time when you are adding dependency, think what will be effect of removing that dependency. Because maybe in future you will not have the bookings and you want to remove the booking. What else must be removed to be able to remove the booking? If you need to remove even something which should stay in the system, the dependency cannot be there between these two applications because you are polluting these dependencies with something which is not needed for that. Use dependency only if the functionality is tightly coupled. Only when the B don't have meaning without A. If only part of the app is tightly coupled, because, for example, you have application and only one report needs some field from another application, and the rest of the application don't need that, don't put that dependency for whole app. Because, as I told, if I remove B, I will need to remove whole A. But I won't just remove maybe the report, which is depending on that. Yeah. Just split that app, remove that report from that app, put it to separate one. That separate app will be depending on the application with the field, and connect these two applications in some way which will not prevent you from removing these parts when needed. Keep interface minimal. Now we are going back to the interface. Keep it minimal. Don't pollute it with unnecessary things. For specific things, create new interface. That's just repeating what I already said. And Last principle, dependency inversion principle. I think you are using that principle, but maybe you even don't know about it. But we will see later. I think definitely at least most of you are using that principle. How to describe that on the car? You have fuel tank, and fuel tank wants to notice you that there is no fuel inside. But the fuel tank knows nothing about the dashboard you are using in your car. Yeah? And he needs to somehow say to that dashboard that there is no fuel, because you can have that dashboard or that dashboard. You can have Tesla or you have something else. Okay, Tesla don't have fuel tank, yeah? We have batteries, for example, in that case. Okay, knows nothing about the dashboard. It means the dashboard is mostly depending on the fuel tank. But the fuel tank is signaling us something. It means the dependency is in opposite than the flow of the control. And that's the dependency inversion principle. You are changing the direction of dependency. Normal is to have dependency in same direction as flow of control. A call B, then A is depending on B and call the function from the B. That's the standard situation. But dependency inversion is changing that directions. And it is tool which help us to implement previous principles, open-close principles, Liskov substitution principles, and these kind of things. And solution for us is events and interfaces, again. Yeah. At the end, you see that we are talking mostly about events and interfaces. Nothing more, but it's more complex things to think and use them correctly. Yeah. That's the example, A called B, A depends on B, that's standard situation. Opposite, A calls B, but B is depending on A. How is possible? Because A call just events publisher and know nothing about the B, which is subscribing that event and answering to that event when it is fired. Yeah? It means A is protected from changes in B. In first example, B is protected from A, because B know nothing about A, but because there are some rules, we were talking about that high-level and low-level applications, business rules versus peripheral things, and these kind of things, we need sometimes to switch that dependency direction, and dependency inversion principle is just about that.
So maybe you've gone down a different road and you said, okay, well, we're not going to make all of these extensions dependent on a common app. We're going to try to keep these all separate, very interchangeable. It's very easy to accidentally go, let's make Bounce depend on the bookings. Well, as we talked about, that will break things. We know that it's still fragile that way. We remove bookings, things go terribly wrong. So to fix that, this last piece, which I think is the part that's a little bit new to people, I hope that most everyone else so far has been going, yep, that's all familiar. What's the new stuff here? The difference here is this. Dependency injection means that we create an extension that makes the connection between two disseparate modules. By being able to use enums and their ability to implement interfaces, we can tell the lower level applications that we depend on information about other parts of the system. So what does that mean for us as developers? This means that in the bookings application, we would create an enum that says what kind of type of amusement is it, and we create an interface that has all those different event calls that we might want to be able to implement, all those functions. Up in the bookings bounce module that sits dependent on those two things, we can then inject into the bookings module a new enum value where we say, okay, there's now a type field that knows about the bounce. We can update the table relationships, we can update and implement new code units. So that way, when things happen, in either of those modules, they're able to call the generic implementation of an interface object and fire an event on that. Just quick check of the room, because there's a lot of people in our workshops that had not done enums and interfaces. Who has written one of those yet? Oh, thank goodness. For those watching the recording later, that was actually a pretty good number of people. So the advantage of this is that by creating a little micro extension on top of two disconnected modules, neither of these applications have ever heard of the other one. That means that later on, if we decide we want to replace the booking system with something else, the cost of the change is to click uninstall. Bounce no longer cares. It's never heard of it. We click uninstall. Both of those extensions go away. Our system is done. It's ready. No problem. We pop in a new extension that connects to a new system. So we created a little extra infrastructure up front to create separate booking system, create separate bounce, and we created a third little extension, which, by the way, in our workshop, it was 5 objects total. It's a very small extension, very easy to manage. That little thing saved us the effort of, later on, we don't have to worry about our 60 customers in the wild of how do we update all of those customers, because now we've changed the dependency tree. They don't have to know about each other. They don't ever have to meet each other. By investing that time in creating the loosely coupled, injected dependencies, we save cost in a very big way past year 1.
It means that dependency inversion principle is, for us, I think, the most used principle from all that. And now you will know that you are using that if you are implementing interface or events and so on. And you will know if someone wants to add dependency in your solution in direction which is not correct. You will say, okay, no. And he will say, but I need that because I need to call that function from that application. Yeah, but dependency inversion is allowing me to make the dependency in opposite direction, and I will just implement some event and some subscriber, and I will solve that problem. Yeah. And keep the architecture nice and simple. Okay, maybe on the first side it will not be so simple, but it will be simple for maintenance. If you find out that dependency should go opposite, use events and interfaces to invert it. Specific to depends on generic. Yeah? Specific application depends on the generic thing. It means the bridge is specific thing. It's solving specific connection between the 2 apps. But the bouncy app is generic thing. That's why the bridge was depending on the bouncy application. Low level depends on high level. Low level, for example, integration with external system. That's low level application. High level is some business process. Unstable, unstable. Already we were talking about that. If you change something really often, put it at the end of all the dependencies. It should depend on others, but nothing should depend on that application, which is unstable. Because if something depends on unstable app, it will be unstable too. And you should check each time you change that unstable app. You need to check again that you didn't broke something on that depending application. If we want to protect A from changes in B, B must depend on A. That's the core of the problem here. Yeah. Dependency could allow us to protect some app from changes in another app. The bridge was something there, and because we had no dependencies between bookings and bounce, they were protected, and the bounce and booking was protected from change in the bridge app, because bridge app depends on them. It means if I break something in the bridge app, it will have no effect or should not have effect on the booking and on the bounce, and they should work. Okay, maybe some process will not work because they can't post something about the bouncy, but For example, posting about the paintball fields will still works. Remember the open-close principle, it's connected, because in open-close principle we were talking about dependencies too. And don't be afraid of that. Don't be soft, be solid. Try to implement these principles into your work. Yeah. If someone tells you, no, we don't have time for that, you will never have time for that until you start to implement it and you save your time because you will have correct architecture in your solution. That's a circle you need to stop someone. Yeah. Nobody have time for architecture until the architecture is in place and you save time on that and you can do that. But you need to start somewhere. But you can start step by step. You don't need to start with everything now. Step by step. Try to think first about the single responsibility things. Don't introduce multiple responsibilities on different ways. Then start with something else and step by step make the architecture better. Yeah.
One of the questions that we got a lot in the workshop is, okay, this is interesting, it's novel, it's kind of cool, there are some parts I like about it. As an aside, all of the code that we created as part of that workshop, including the Bounce application, all of that, the completed code will be on my GitHub next week. You can crawl through it, have fun with it, play with it. But the question we got from workshop attendees is, okay, I like the ideas of this, but I have to go back to a job. They're not really that interested to hear about the cool new plan I have to break up this monolith. They don't have the time. We don't have the interest. We don't have the resources. So for the folks who are going back to report to a product manager or a department manager, they ask the question of how can I convince that person that architecture matters, because that was the point. The architecture matters. We have to champion it because no one else will. Well, start small and start from the outside moving the way in. Just like testability, where you can start small by targeting support cases first. Start little. Make those little changes. So clients that are working with printers, web shops, integrations, these are your first targets because they're that outermost layer. They might be core business application, but they're connecting different things. So work your way out to in. What are the advantages you can tell one of those folks in charge is that those small changes, those little bridge apps, they're tiny. They're half a dozen objects. Those are much, much easier to delegate to people. And you can delegate them to juniors. You can delegate them to external. It helps you bring people that are new to the product and say, let me teach you all about building bridge apps, and you're going to be my bridge app guy. I don't have to ever think about it again. Wonderful. And they're reusable. They're often very, very simple patterns that you can just rename the fields, rename the tables, move on with your day. We have talked with a couple of different partners in the channel, for example, that are ISVs offering solutions on AppSource that because they followed this careful architecture around making their code open, making it possible to inject these dependencies, they were able to create scenarios where they built between them those connection bridges between their separate products. And as a result, when they go to do demos to customers of their product, they usually show the other guy's stuff. Because the customer sees this is a complete solution, I don't have to spend the time and effort to go, okay, I didn't have ship it, they work with Tasklet Factory, I don't have to wonder how does my warehouse guy scanning this code get to the shipping organization. It's just built in. It comes pre-installed. So that makes a real strong case of if you architect things, you potentially can sell more. Well, that's nice and all, but then also there's the, okay, lots of us have clients. Who's going to pay for this? Clients aren't going to want to. Who's had luck with getting clients to pay for testing automation? I saw one quiet, embarrassed person in the back. So when it comes to selling Solid, you're going to pay for it, just like testing. Later, You might pay for it later. And if you're working with a client organization where they have lots of turnover, they might go, great, I'd love to pay for it later. Thanks, here's the credit card. But if you invest in that architecture up front, you pay less overall. That bar stays flat that whole time. You don't have those huge jumps. I'm working with a customer right now that's breaking up a monolith. We've done the cost projection of all of the different things that we've done over the past 3 years to their monolith, the time spent on defects, the time spent on figuring out different changes, the time spent in team status meetings, get 3 different managers to approve each change. We've done that cost analysis, and it's going to actually cost them less money to have us spend all the time to break up that monolith into the apps, because they were willing to look at the 3 or even 5-year ROI of, does that time actually get me anything? Yes, later, it gets you a bigger budget that you can put into, let's do some new good stuff. Let's not just spend money to keep the lights on. So it's easier to do big changes. It's less time that you're going to spend on defects, because customers spend time on defects too. The truck's here. I can't print. I need to ship. And then, of course, we also get into the fun, wonderful world of some of you folks are going to go back on Monday. And we're not ticking along here. And some of you are junior devs, and you're going to go back to the senior developer and go, I've got this cool plan. And they're an old nav fossil like we are. And they go, I don't have time for that. Nav was better, whatever. I don't want to hear it. We hear it too. The segregation principle keeps you from having to fix the fixes. I don't know how many hours I've spent going, I fixed it, and then more hours fixing what just got fixed. It also becomes much easier for senior developers who are a little resistant to working with some of the new ways to say, okay, well, tell you what, you don't have to worry about building these connectors to an API. You don't have to worry about OAuth. We just taught this new guy all about building the micro application necessary, the eventing structure necessary to build the bridges to talk to external APIs. You don't have to worry about that. You just worry about posting code units. Cool. So for those, it's easier to break up the projects. And smaller becomes faster because it becomes repeatable. You're able to be cheeky. You can copy and paste code from different projects and just rename the tables you're pointing at. And it's also a heck of a lot easier. I don't know how many times I've debugged a monolith, and I got the wonderful debugging messages where it would say, oh, sure, no problem. The problem is on function line 932 in this 3,000 line code unit. Trying to find that is much, much harder. And if you're building pipelines, you're going to be able to pinpoint exactly where in the pipeline things are failing much, much faster. So you can make the case to some of these different people with some of those different theories, and yes, this slide deck is going to be available later. You don't have to have taken notes on those. So all of these costs do build up. Someone is going to be paying for those costs, and if you're not paying it intentionally with good design, you're going to pay for it unintentionally with bad design.
Yeah. Remember the principles? Single responsibility principle, open-close principle, Liškov substitution principle, interface segregation principle, and dependency inversion principle. Solid. Yeah. Don't forget them. Try to implement them. Try to think about them. And I hope that your design and architecture will be going better and better, and we will go forward with same price for each change you will need to implement in your system. We have 7 minutes for questions. I see already some hands up for the question there. Okay.
Just to the topic where I said pollution of the apps. Because in this example, you showed us it was one company. So you developed several apps for one company. So if you deinstall an app, it's not relevant anymore for anyone.
Exactly.
But if you're working on product, and you say, okay, this customer don't need this app anymore, then it's not relevant for, it is relevant because another customer maybe uses it.
Yeah.
So in this case, because you also mentioned then the strategy that you say, okay, if two apps are connected together, just making a third app, and the third app just uses a collector for same procedures. For example, date management or, I don't know, posting in the same way. This is not a pollution then. When I just say, okay, I just move functionality and in some customers there's only one app existing, this doesn't count as pollution then.
One of the recommendations that we have on pollution of interfaces, if you haven't used it yet or heard of it, folks in the room still, the argument table pattern is a fantastic way of giving a consistent signature that is extensible, so that way you can consume only the data you need. And we recommended a lot in our workshop that when you're building a lot of those interfaces, the pattern of handing specifically an argument table that has all the different values you need makes it easy for depending apps to say, I need 10 extra bits of info, and they can inject into that argument table via table extension those new fields, and the application that depends on those 10 fields can see that those are present. You'll find that there's cases in Base App where they do things like that, where they go, if field number exists, then we're going to do these things to make it loosely coupled.
Also, you can say it's like a design pattern in the app, like a README, for example.
Yeah.
Yep.
Definitely, there are multiple solutions for each case. Yeah, the dependency could be in different directions, or maybe it doesn't need to be there, and you can replace that with some other functionality, like using recordref or using API and calling API of the second app and making them loosely coupled without the dependency. There are multiple solutions, and the question is, you need to think about what will be easier for you, measured in the cost of change in the future. Yeah? That's the main thing, and the decision is on you as an architect. If it is better for your company because you are used to that, maybe it's better than someone else will use other way because they are used to that way. Yeah? It means architecture is not exact thing, and you can see it everywhere, that architecture of buildings, even when it is same architecture, it's totally different building. Yeah, because the one who made that architecture made own decisions measured by some measurements, and the result is different. It's really like painting the picture, some picture or something. If you have two people doing same style of painting, the result will be different. Yeah? Even there are same rules, for example, applied to that. It means maybe you have some ways which are good for you, and it's okay. Yeah? If it fits into these principles, and I think it will fit, why not?
Yeah, the thing with the designing pattern, that was good.
Yeah.
To think like a README of it.
Yeah, exactly. Okay, there's another question here.
Well, thanks for the session first. So we are a dinosaur company, so we have our solution as a monolithic thing since 20 years and also being on our journey, so it's really nice to see these patterns. We right now have one funny little case, and I really wonder if the bridge apps will help on that, is something like we have a cyclomatic dependency between two partners. So while the one says, I have something for you, you can get it, the other one says, yeah, we have something for you as well, you get it from us. So how to apply a pattern on top of this one? Will it be one bridge for both? Will it be two bridges which are going vice versa? So what would be a preferred way here? And who's responsible for it?
That's, I think, the first question. Who will be responsible for that?
Yes.
Yeah, if each one wants something what they are responsible for, then there will be two apps. And they will be responsible for these two apps. And if there is conflict between the functionality of these two bridges, then they need to communicate somehow.
Yes.
Yeah? And say, okay, it's your thing, or no, it's your thing. yeah, there is no other solution than that. Yeah. But definitely, yeah, the cycle could be solved by the bridge or something else. But first thing is the responsibility. Yeah. There can't be app for which both partners are responsible. No, it will not work.
Yes.
And that's the general idea of the Bridge app is you're injecting into it whether you want input to go into it, which you can do via eventing in the receiving app, or if you want to potentially expose functionality that then you can actively call, and that becomes those enums and the interfaces. So it depends a little bit the direction of information flow and that sort of thing. But of course, events can pass VARs back and forth, so sometimes events are their own little procedures. And while we have the last 30 seconds, I do want to catch one more question.
Fine. Yeah.
Our microphone cubes.
Let's imagine I have a solution which is kind of monolith, and yeah, it's difficult to extend and so on. So which way is to move? Which way is better? Is it like refactor this step by step until it's a better architecture, or should I create a new one with the good architecture and somehow migrate to it?
Great question, and the short answer to that is it depends, of course. But you can take both approaches. It depends on their willingness to invest in the refactor before they move to a new version. I've done both implementations where we wrote a whole new extension framework and migrated into that as a clean, brand new start, because architecture is the reflection of decisions past. If those decisions past aren't relevant anymore, that's an opportunity to do a whole cleanup project, and that's an opportunity to make things a little bit better. If all of those decisions of the past are still relevant, then it's a great opportunity to say, let's migrate to BC, let's migrate to the monolith, and then start breaking pieces at a time based on those different, work our way out into the middle of it. So you can take a slower process where you can take a monolith over the next 3 to 5 years and just break off parts and slowly work your way in.
And it's what Microsoft is doing now. Yeah? We had a monolith, and now they are started from the system level and put all the system things out of the monolith to separate apps. And now the new things are already implemented in as apps. It means new things you can or should implement in the new way, and in between start pulling other parts out of the monolith to break it. Yeah, but all depends on the capacities and all that things around. But yeah, that's
Okay.
more complex.
Thanks.
But
Thank
we are
you.
out of time, so
Yeah,
thank
we
you,
are out of
everyone.
time. Thank you very much. Hopeful that it was something positive for you and you will use it. Thanks.